So just like on arithmetic sequence, which also has an arithmetic series, we also have what we call a geometric series. For example, if we want to add terms of a geometric sequence to form a series. Suppose we want to add the terms of a geometric series. How are we going to do that? So we are going to jump in and write the formula. We are going to prove it later for the geometric series. First, we know that a for this, a is equal to 2, and we know that r is equal to 2 also for this series. We are going to write a formula, an easy beautiful formula, which is a times r to the power n minus 1 over r minus 1. So using this formula, we can therefore calculate any sum on this series. So first, a is still your first term, r is our common ratio, and n is the number of terms. For example, let's try to calculate just the first two terms of the sequence, just these terms. We can see that this is t1 and t2. If we add these, we are going to get 6, as you can see. Let's try and use the formula and see if we are getting the same answer. Right, so I'm summing the first two terms, so that's going to be s2. So I'm summing the first two terms, this is s2, right, which is going to be equals to our a is 2, and then r is also 2, to power our n is 2, because I'm summing the first two terms, minus 1 all over 2 minus 1. So this is what I'm getting from substituting from the formula. A is 2, r is 2, n is 2. Okay, we can easily simplify this by saying that this is going to be 2 and this is going to be 4 minus 1 over 1, which is going to be 2 multiplied by 3, which is 6. Exactly what we see from adding these two terms. But then we can use this to calculate and find larger sums, like 100 terms of the pattern, 100 terms of the series. We can sum those by using the formula. So let's do S10. So S10 is going to be our a is 2, r is 2 to power 10, the number of terms, over 2 minus 1, and we can therefore use our calculator to substitute that. Okay, so this is 2046. That's 10. So let's try to do the sum for the other series. So we have 3 plus 3 over 2 plus 3 over 4 plus 3 over 8 plus ... Okay, we have a equals to 3 and r equals to half. Okay, so Sn, the formula is equal to a r to the power n minus 1. Very simple formula, over r minus 1. Let's say we want to find the sum of the first 7 terms. So S7 is going to be equal to a, which is going to be 3, r, let's take r is half, to power 7, that's n, minus 1 over half minus 1. So let's use the calculator to find that. So as you can see, this is going to be 5,95. 5,95. So this is S7, the sum of the first 7 terms of this series. So there are types of series which converge and there are types of series which diverge. For those which converge, they have r in the range of -1 and 1, and for those which diverge, they have r not in this range. It will diverge because r is equal to 2, which is not between this range. Right? And will this series converge or diverge? So this one will converge since it has r equal to half, which is in the range of -1 less than r less than 1. So for the series which converge, we can calculate the sum of all the terms in the series and get a finite number by using the formula. So if a series has r in this range, we can use this formula to find the sum to infinity. So using the last example, we can calculate the sum to infinity since r was equal to half by substituting a as 3 and then r as half, 1 minus half. So what are we going to get? We are going to get that the sum to infinity is 6 in this case. So that's easy how we calculate the sum to infinity. So long as r is in that range and we have a geometric series, we can therefore calculate the sum to infinity.